Hello friends, my name is Sadiq and this chapter let's talk about rational numbers, and before we can actually talk about this, let's talk about how did the whole concept of numbers came up. When man in fact wanted to count things, things like what? Like sheep, like number of trees or number of children he had, or basically fingers, let's say. So he had to just count like 1, 2, 3, 4 and he crossed it. This is one of the systems how numbers came up. Like so we have 5. And like this, I have another set like 6, 7, 8, 9, 10. So I can see that when he wanted to count number of things he had, he developed things like 1, 2, 3, 4 and things like that. So now it came like 1, 2, 3, 4, 5, 6, 7 and it goes on like that. Okay. Now I can actually use and call these as natural numbers and use these numbers to solve the first equation that says x plus 2 is 13. Alright, so when I say that I have x plus 2 is 13, let's talk about a little more about equations before we come to this. X plus 2 is 13. Now what exactly does the equals means to you? It says, let's say I have 2 is equal to 2. That makes sense, right? So similarly, like 5 is equal to 5. Even that makes sense. Now can I add, let's say to this, can I add 2 here and 2 here? Yeah, see what happens. 2 plus 5 is 7 and 7 again. Even that makes sense. It means I can add same things on both the sides of equals and it still makes sense. Right. So how do you solve this equation using this logic? Okay. Now let's say I have 5 is equal to 5. Can I subtract something like 5 minus 2 and minus 2 on both the sides? What happens here? 5 minus 2 is 3 and it's 3 back again here. It makes sense, right? So same way, if you talk about solving this means just keeping x on one side and finding the value of x which would satisfy the equation. So how will I keep x on one side? I don't want this 2 here. So the best way is, can I add something or subtract something on both the sides of equals so that I don't have this 2 anymore? So I can just take minus 2 here and minus 2 here. I'm doing the same thing on both the sides of the equals, which is legal in maths. Now what happens here? 2 and 2 goes off, right? X is left alone and that is 10. See, I understand this. Okay, if this guy was 13 here, it would be 11. So I can see that that's the solution, right? Now, how did I solve this? Just to make x alone, I have to remove 2 from this side, correct? So I just took minus 2 and minus 2 on both sides. I know that I can do the same thing on both the sides. I got the value of x, and now this is exactly a number which comes somewhere, let's say here, 7, 8, 9, 10 and 11. I can see it is here. Now natural numbers are enough to solve the first equation. And why are they called natural numbers? Simply because they are counting numbers. They did not need any 0 or a negative number. So we understand they are natural numbers. Just came up counting things what man had around him. Well, let's go ahead with the next question here. Let's say like this guy. So this comes up with a mathematical problem. So when I say that I have to solve x plus 5 is equal to 5. In this case, I should not have 5 with x, correct? So what should I do on both the sides of the equals? Obviously, I will take minus 5 and 5 minus 5. I'm just trying to work on this guy that there's nothing with x, right? So I can see that becomes a 0. X plus 0 is 0, or I can just say x is 0, right? Now x is 0. Now who is 0? I don't find 0 here. Isn't it? So now we had to come up with a new set of numbers which includes a zeros. So fine. So let's call them as whole numbers, right? So I have 0, 1, 2, 3, 4, 5, 6, 7. So the number system improved a little bit or included one more thing called a 0. Now, would that be enough to solve all kind of equations? Let's go with the third equation there. Okay, let me do it here. Now I see that the third equation there, I have x plus 18 is equal to 5, right? In this case, I would not like to have 18 with x. X should be alone. So what should I do? How will I remove 18? So according to the logic, we know that I have 18. So subtract 18 on both the sides. 5 minus 18. So that goes like x, that's a 0, plus 0 is gone. And 5 minus 18 is minus 13, alright? Now x plus 0 is x again, is minus 13. Now who is this minus 13? Do we have something like negative numbers here? No, we don't have. Here also we don't have negative numbers. We have a 0 though, but no negative numbers. Now who is this minus 13? So now they came up with another set of numbers called integers. We call them as z. So here I can see that there is a 0, there is 1, there is 2, there is 3, and all these numbers which are actually natural numbers and a 0. This makes it whole numbers, and I have negative numbers, -1, -2, -3, -4, -5, like that till again the infinity, here infinity there. So now we understand how these three set of numbers came. Right, now are these enough numbers to solve all possible equations? Not exactly. Let's see what happens here. Now let's come up with another problem here. So let's say the problem is like that. That is 2x is equal to 3. Now before I do this, let me tell you something more about equations. Let's say I have 5 is equal to 5. So we just learned how to add same things on both sides or subtract same things. But can I divide same thing on both sides? Let's say 5 by 2 and 5 by 2. Yes. So that's the answer they're saying, logically saying. Or let's say another example, I have 20 here and that is equal to 20. That is correct. Can I divide both of them by 5? Let's see what happens now. 5 1 times by 4 times that. 4 is equal to 4. This guy is logically equal, right? This makes sense because 4 is equal to 4, correct? How did that come? By dividing both the sides, which are 20 by 5. So it means it's legal to divide both the sides of the equation with the same number. So if I do it here, what do I get? I get 2 is gone. This I'm doing so that I can get x alone. That's what's solving for x. 3 by 2. Now this guy, I don't have it in this or in this or in this. So I don't have it in either of this. Now what should I do? Now I should come up with another set of numbers. These are called as rational numbers. Alright, that's what we're talking about today in this chapter. These are called rational numbers where you have 3 by 2, which is not in fact this or this or this. They are fractions basically, where 3 and 2 both are integers. Now how do I understand that? Let's go with the next one there. That is 5x plus 7. Alright, let me do it here itself. In this case I see that 5x plus 7 is 0. Now can I first remove 7 from here? That is 5x plus 7, let us say minus 7 is equal to minus 7. I'm doing the same job on both the sides, correct? Now can I solve this? Like 5x 7 minus 7 is 0. Yes, it's minus 7. Or 5x plus 0 is 5x itself. It's minus 7. X is what now? Can I divide both the sides by 5? Yes. That goes like 5 and 5 is gone, and x is equal to minus 7 by 5. Now this guy is negative. This guy is positive, but this guy is negative. So now who are rational numbers? So rational numbers are all those numbers. Let me define that now for you. So let me erase this part. So rational numbers are all those numbers which belong to a set called Q, where x looks like, let's say, p by q. And who is p and q? P and q is any integer. It can be a positive number or a negative number, right? And they can be full numbers like integers basically. So I can write that p and q both belong to z, integers, right? It can be a 0 also, but except q should not be equal to 0, right? If q is equal to 0, then the whole thing becomes infinity. It is not defined at that point. We'll discuss about this a little later. We'll just talk about rational numbers and the definition of that. But these are rational numbers which are written in the form of p by q, where p and q both are integers. It means it can be positive or negative, like this. I have x is 3 by 2, where p is 3 and q is 2, and both of them, 2 and 3, belong to z. They are integers, right? Similarly, if you talk about that one, that is minus 7 by 5, I can see that p is minus 7 and q is 5, and minus 7 belongs to z, 5 also belongs to z. So that's a rational number. It can be a positive number or it can be a negative number, and it can be looking at the form p by q. Right, now one question: do you think that 5 is a rational number? Does it look like p by q? Yes, it does. How is that possible? I can write 5 as 5 over 1, where 5 and both are actually integers, right? Or I can write 5 as what? I can write as 10 by 2. Yes, 2 1 times 2 5 times. So these both are looking like what? P and q, which are rational numbers. Simple as that. So I can say all numbers, even natural numbers, are in fact looking like p by q, if at all you divide all the natural numbers by 1. Yes. So we understand this argument. Very simple. Now let us understand more about different types of numbers. Now before I can finish this, I would like to solve these equations in another way which is generally solved in your school. Okay, so now That was the basic idea how I solved. Now let's come back with this. X plus 2 is 13. Now how would you solve this, or you've learned to solve this like this? If I put x2 on the other side, the plus sign will become minus and x becomes 13 minus 2. So when plus 2 goes there across the equals, it becomes minus 2. So that's how we understand things. But the actual way of working out is x plus 2 is 13. Then what I do is I do the same thing on both the sides of the equals. That means I subtract 2 on both the sides of the equals. That's all about it. So that becomes what? This becomes 0. That is x plus 0 is 11 and x plus 0 is x itself. Okay, this is the way exactly it is built up, but for convenience we just put the thing there and it becomes a minus sign. It's all the same here, right? What happens to the 2 here? In fact, it disappeared because 2 minus 2 is 0. That's all about it. In terms of multiplication, let's say that is 2x is equal to 3, and what I do here is I either divide both sides by 2, or what we generally do is we in fact write this as put 2 below this, right? That is 3 by 2. Okay, so when it's multiplication here, it goes as division. When it's addition here, it goes as subtraction. If it is subtraction, it goes as addition. That's the logic we generally follow in this course, but in fact this is how it works. I divide both the sides by the same number and I get x is equal to 3 by 2. So I hope you understand this, that you're not confused the way I taught you solving these equations and what the way you've learned. Both are same. That's the exact way of doing it, and that's the way we follow it, right?